Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today we'll go into Chapter 7, Equilibria. We'll discuss about buffer solution. So we will explain how buffer solutions control pH and also calculate the pH of buffer solution with given appropriate data. So this is the definition of buffer solution. So buffer solution, it's a solution that can resist, control, or maintain changes in pH when small amount of acid or alkaline are added. So buffer can have its own pH. So therefore we can have an acidic buffer, alkaline buffer, or even a neutral buffer. So this is an example of an acidic buffer. So acidic buffer is from the mixture of a weak acid and the salt of itself. So this is the mixture of the weak acid and its salt. So where the weak acid dissociate partially and the salt dissociate completely. So in the mixture, the buffer must take the responsibility to get rid of the H plus or OH minus added. So if there's a H plus added, so the buffer must react with it to maintain the pH. So therefore, we have CH3COO minus from the mixture to act as a proton acceptor to accept the H plus added to form CH3COOH. So what if there's an OH minus added? So there will be CH3COOH to act as a proton donor, donate H plus to neutralize OH minus. So CH3COO minus and H2O will be the products form. So next is the example of alkaline buffer. So where we have a weak base, which is ammonia, and its salt. So this is the mixture of the buffer. So when there is H plus added, so NH3 with the lone pair will be the proton acceptor to neutralize the H plus added. So when there is OH minus added, so ammonium ion will be the proton donor. So it donates H plus to neutralize OH minus to form NH3 and H2O. So this is how buffer maintain the pH. So we could also make use of these formulas to calculate pH of a buffer solution. So this formula actually it is derived from the Ka of the weak acid in the mixture of buffer solution. So this is the Ka of the weak acid. So in order to get the pH of the buffer, we need to get the concentration of H plus. So from there, we could actually negative plot the concentration of H plus to get pH value. So but we got to do two assumptions where we got to assume that the weak acid in the buffer solution doesn't dissociate at all. So therefore, the concentration of HA is the initial concentration of the acid. And so the concentration of A minus are all from the salt. So it will be same as the concentration of the salt. So with these expressions, we could actually get the negative lot of concentration of H+, which is the pH of the buffer. So we have negative lot Ka and negative lot H+, plus negative lot concentration of salt over acid. So this will be the pH and this will be the pKa. So we're going to move this to the left to have positive lot salt over concentration of acid. So this is the formula that we could use in order to get the pH of a buffer solution. So let's go into example of past year questions where we will move into October-November 2018, paper 41, question 4. So let's see the first question where we have buffer solution are used to regulate the pH of a solution to keep its pH value within a narrow range. So the question requires us to make use of two equations to describe how hydrogen carbonate ions and carbonate acid control the pH of blood. So there will be 2 marks for this question. So it will be 1 mark for each equation to go. So what if there is H+ added? So we will have hydrogen carbonate ion to be the proton acceptor to neutralize the H+ added. So the product will be H2CO3. So next, if there is OH- added, the carbonic acid, which is H2CO3, will be the proton donor. So where it will donate H+, and it form HCO3-, and to neutralize OH- to form H2O. So these are the 2 equations where we could get 2 marks. So next to go, so there will be given Ka for ethanoic acid. And when ethanoic acid is dissolved in water, an equilibrium mixture containing 2 acid-base pairs is formed. So they want us to write the equation for this equilibrium and also indicates which is the acid and base. So when ethanoic acid dissolved in water, so we will have dissociation of it to get COO- and H3O positive. So from here, we could actually see CH3COOH, which is ethanoic acid, it donates H+. So in order to form CH3COO-. So therefore, CH3COO-, it's an acid. And H2O will accept the H+ in order to form H3O positive. So here we could see H2O is the proton acceptor. So it will be a base. So for the reverse reaction to go, we can actually see H3O positive will donate H+. So in order to form back H2O, and COO- will gain H+ in order to get back CH3COOH. So if it is a proton acceptor, it will be a base. And H3O positive is a proton donor, so it will be an acid. Okay. So for the next question to go, we are required to do calculation to find the pH of the buffer solution. So what we have here, we have ethanoic acid and also NaOH. So we have to move into the reactions of both of them. So for the reaction between ethanoic acid and NaOH, so a salt and H2O are the products. So with the given information, so we have the volume and also concentration of ethanoic acid, and also volume and concentration of NaOH. So first of all, we need to get the mole of them. So with the formula mv over 1000, so we can actually get the mole of NaOH, which is 0.003. And also the same for ethanoic acid. So we have the volume and also concentration. So with mv over 1000, we could actually get the mole of ethanoic acid, which is 0.0075 mole. So with the mole of them, we could actually see ethanoic acid, it's in excess, and NaOH is the limiting reactant. So this is excess, and this is limiting. So all NaOH will react with ethanoic acid to form the salt. So we will have the remaining of acid, which is the ratio of acid to NaOH is 1:1 ratio. So 0.0075 mole of acid will react with 0.003 moles of NaOH. So the remaining of ethanoic acid will be 0.0045. So since it is 1:1 ratio, and 1 mole of ethanoic acid will react with 1 mole of NaOH in order to form 1 mole of salt. So if we have 0.03 moles of acid reacting with 0.03 moles of NaOH, so there will be 0.003 moles of salt formed. So with all this information, we could actually put them into the formulas in order to get the pH of the buffer. So where we have here, pH equals to pKa plus lot. Concentration of salt over concentration of acid. So initially, the Ka of acid, ethanoic acid is given. So where we have negative lot, 1.75 times 10 to the power of negative 5 plus lot, concentration of salt. So here we have the mole of salt, which is 0.003. And to get the concentration, so we have to over the moles to the volume of the mixture. So the volume of the mixture, there will be 50. So 50 cm cubed, it's equals to 0.05 dm cubed. So in order to get the concentration of the salt, there will be 0.003 moles over 0.05 dm cubed. So for the concentration of acid, there will be the mole of the acid remain over the total volume in dm cube. So with this, we could actually get the pH of the acid, the buffer, which is 4.6.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help. Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie, we'll see you next time. Bye-bye.